video, we're going to derive the basic trigonometric formulas, the fundamental formula of trigonometry, and two formulas that can be derived from it. We're going to obtain the basic formulas of trigonometry, and for this, we'll consider an acute angle alpha. The one shown here will form a right triangle from this by drawing from the base of perpendicular. Wherever we'll like, for example, here, and this makes our triangle. It's a right triangle because it contains an angle of 90 degrees. In a right triangle like that, the shorter sides, these, are called the catheti, and the longer side, which is this, is the hypotenuse. Suppose in our case, we call the catheti A, B, and the hypotenuse H. Pythagoras' theorem says that the sum of the squares of the lengths of the catheti, in our case, so A squared plus B squared is equal to the square of the length of the hypotenuse H squared. So let's now divide this expression by H squared on the left side. So we divide each of the atoms to give A squared over H squared plus B squared over H squared. And on the right, we have H squared over H squared. Well, if we can write the left side as A over H squared plus B over H squared, and this is equal to 1 because anything divided by itself is 1. Now, let's calculate the trigonometric ratios of our angle alpha. First, remember the sine of an angle is the opposite cathetus divided by the hypotenuse. In our case, sine alpha is B divided by H. Cosine is the adjacent cathetus divided by the hypotenuse, in our case, A over H. This is what appears in the formula we derive. We can substitute A over H squared for the cosine of the alpha squared and B over H squared for the sine of alpha squared, and put this equal to 1. So we've obtained what knows as the fundamental formula of trigonometry. So we've obtained what's known as the fundamental formula of trigonometry. Let's switch around the terms on the left, putting the sine squared alpha plus cosine squared alpha is equal to 1. As you can see, the fundamental formula of trigonometry is nothing more than a trigonometric version of the Pythagorean theorem. For continuing, notice that we obtain this formula using an angle that is acute, in other words, with a value between 0 degrees and 90 degrees, or in radians between 0 radians and pi over 2 radians. But this formula is also satisfied for other angles that are found in the circle, and in fact is valid generally for any angle. And you can show this as an exercise. Now let's obtain the two other formulas we mentioned at the beginning based on the fundamental formula of trigonometry. To do this, we simply divide all the terms of the fundamental formula by sine squared alpha and by cosine squared alpha respectively. First, let's divide by sine squared alpha on the left. When we divide that 2 items by the sine squared alpha, we get sine squared alpha over sine squared alpha plus cosine squared alpha over cosine squared alpha over sine squared alpha equals on the right side 1 divided by sine squared alpha. So we have sine squared alpha over sine squared alpha, which is 1. So we have sine squared alpha over sine squared alpha, which is 1, plus cosine squared alpha over sine squared alpha, and cosine over sine. Remember, is cotangent to cotangent squared alpha is equal to cosecant squared alpha. Remembering that 1 over sine is cosecant, and this our first derived formula. So next, we will divide both sides of the fundamental formulas by cos squared alpha by cos squared alpha to give sine squared alpha over cos squared alpha plus cos squared alpha over cos squared alpha equals 1 over cos squared alpha. So sine of a cosine is tangent. So on the left side, we have tangent squared alpha plus cosine squared alpha over cosine squared alpha, which is 1 equals, and this is equal to remembering that 1 over cosine squared alpha is secant squared alpha. We'll switch around the items on the left side so that the 1 appears in front, giving 1 plus tangent squared alpha is equal to secant squared alpha. Formulas is important to take account of the quadrant to which the angle belongs and to choose the appropriate sign. So that's all for this video.